screw gauge. Okay, meter scale was there, then vernier scale, and the third is what? Screw gauge. Now what is the necessity of going to screw gauge? So that all again it is a matter of accuracy. Now vernier meter scale least count is 0.1 centimeter or 1 mm. This is meter scale. Vernier scale calipers 0.01 centimeter or 0.1 mm. That is, it can measure up to 2 decimal digits. If you want to measure 3 decimal, after the decimal if you want to measure 3 digits, then that's not possible through vernier scale. Then you have to take more accurate instrument, that is what is screw gauge. So in the screw gauge, working principle is almost the same, formula also remains the same. Here the least count will be 0.001 centimeter. After decimal there are 3 digits, so it can measure up to 3 digits after the decimal place, or multiply by 10, you will get this as 0.01 mm. So these are the least counts. Standard scales have this. Okay, now in meter scale if you see, or in the vernier scale, it had a normal mean scale. So here also you have the normal mean scale, that is each reading 0, 0.1, 0.2, 0.3, 0.4 and then 0.5 centimeter. 5 is not 5 centimeter, it is a 1 mm each. 1 mm, 2 mm, 3 mm, 4 mm, 5 mm, 6, 7, 8, 9, 10 mm is equal to 1 centimeter. From here to here it is 1 centimeter, is it not? Like that. So it is a normal mean scale. The mean scale is same like your meter scale. And then if you check out, you had 2 jaws, right? You had 2 jaws, is it not? The lower jaws, where one jaw was fixed and the other jaw was movable, because that was fixed to the vernier scale, and vernier scale used to slide. In between that you used to place the objects, if you can recall. This was connected to vernier, so this gap can be adjusted, is it not? Similarly, this is the fixed jaw and this is the movable jaw. So when you rotate this, I'll speak about this also, the spindle will go forward or backward. Okay, and then you can adjust the object here in between these 2 jaws. And then you had a sliding scale in vernier, right? Sliding scale, the extra component was the sliding scale, which we used to call it as a vernier scale, and that vernier scale had 10 divisions, is it not? Standard vernier scale had 10 divisions. Here instead of the sliding you have a rotating, it can rotate, is it not? It is a circular scale. So here you are having a circular scale. Okay, you have a circular scale that was sliding, here it can rotate. So there is a circular scale and that had 10 divisions here, and then here you have 100 divisions. 100 divisions are there in the circular scale. You can have more also. So this is 0, right? This is a circular scale. 1, 2, 3, 4, 5, like that. Even you will be having something like this. I have just shown the front view. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. up to 100. Okay, so this count will be how much here? This count will be 99, and plus that 0 will be 100. Is it clear? So those that will be the representation of the circular scale, that is replaced by the sliding scale, which had 10 divisions. Here it has 100 divisions. Now here basically as I told you, screw gauge, it will give least count which is lesser than the vernier scale. Okay, to have more accuracy we have to use this. Suppose for example, if you want to determine the diameter of a thin wire itself will be very thin. If you want to measure the diameter, you have to have more accurate instruments. So that we will go through the screw gauge. Now what is the least count formula here? Their least count was 1 MSD minus 1 VSD. Here the least count formula is pitch divided by number of divisions on the circular. That's it. Here it was sliding, here it is circular, which has 100 divisions, and here it has 10 divisions. Main scale is the normal thing. Okay, pitch divided by number of divisions on the circular scale. There is a formula for the least count, which you have to remember. Very important formula. Now here what is the basic thing? What is a pitch? What do you mean by pitch? What do you mean by pitch? So pitch means it is the distance moved by the circular scale. What is it? I'll write the definition here. Distance moved by the circular scale on the main scale. On where? On the main scale. Main scale is also mm scale, right? It is also because one division is equal to 1 mm. Main scale or the mm scale when the circular scale scale is given one complete rotation, that is the pitch. number of divisions on the circular scale. In standard thing, what happens in the standard screw gauge? Okay, in the standard vernier scale, what happens if you make both the jaws to coincide? The 10th division on the vernier scale, 10th division on the vernier scale will coincide with the 9th division on the main scale division, is it not? So here also, pitch, what do you mean by pitch? Pitch is the distance moved by the circular scale on the main scale when the circular scale is given one complete rotation. So one complete rotation means basically, suppose for example say it was coinciding. Okay, initially the circular scale was here. Say this is, say suppose for example this was some 9 mm, this was 8 mm, and this was some 7 mm. I've just taken 9, 8 and 7, just assume. Okay, one division is 1 mm, is it not? 7, 6 and then so on. Okay, now when you are giving one complete rotation to this circular scale, okay, circular scale, one rotation, I hope you understand. Okay, it has 100 turns, 100 markings, is it not? 0, 1, 2, 3, 4 etc. up to 99, together it is 100 including 0. So when you are giving one complete rotation, okay, either forward or backward, when you give one complete rotation, the distance that the circular scale moves on the main scale, suppose for example say, just say I moved this circular scale, I gave one complete rotation to this, and now it is somewhere here, it is coming somewhere here, it is coinciding here, that is, it is coinciding on the 6th mark. Before it was at the 9th mark, now it is on the 6th mark when you are giving one complete rotation. So how much distance it has advanced? 1, 2 and 3 mm it has advanced, correct? So pitch is 3 mm. So what is pitch? Distance moved by the circular scale on the main scale. It is moving on the main scale when the circular scale is given one complete rotation, that is only called pitch. Here in the standard scale, in standard screw gauge, what happens is it will advance by 1 mm, not 3 mm. 3 mm was just an example I gave you. It advances by how much? Pitch is equal to 1 mm. That is, when you give one complete rotation, it will just move one division forward. Is it clear? So that is the pitch, 1 mm. And standard screw gauge has how many divisions? I told you it has 100. You can have 50 also. To increase accuracy, you can have 200 also. Okay. So least count is equal to pitch. Pitch is 1 mm divided by number of divisions, 1 by 100. So 1 by 100 will become how much? 0.01 mm. 0.01 mm is also equal to how much? 0.001 centimeter. So the least count is 0.001 centimeter, means after the decimal you can measure up to 3 digits. Okay, so accuracy is increased. Now how to take the reading? Same formula again. I'll just write the formula. Procedure I have explained in vernier scale. Same thing you have to do. Total reading is the main scale reading, that is same as the mm scale, correct? Mm scale, main scale reading plus coinciding vernier scale division. Here instead of coinciding vernier, you have coinciding circular scale division multiplied by the least count. Here you have to see which division of the circular scale is coinciding with the reference line. Okay, this is the reference mark. Okay, suppose for example say you have placed an object here, you placed an object here, okay, and say this is what is the condition. Okay, instead of 0 being here, let us say in the condition now 0 is somewhere here. This is say some 45. Okay, 0 has gone up, is it not? Something this line, this 45th mark is coinciding with this line. Okay, you have placed an object. So what is the main scale reading? Check before this how many readings of a main scale reading are there. So this is how much? 0, 1, 10, 11, 12, 13, 10, 11, 12, 13, 14, 14 mm, right? 14 mm, because each division is mm. So 14 mm have already passed. Okay, so main scale reading is 14 mm. Coinciding circular scale division, as I told you, in this case if you rotate it, correct, if you rotate it, automatically it's not a necessity it should be 0. Any scale can number can coincide. If 45 is coinciding with this reference line, this is the reference line with which the circular scale is coinciding. So that is 45 multiplied by the least count, 0.001 centimeter, and with the help of that you will get the total reading, which is almost same as the vernier scale. Is it clear? So least count formula and the total reading. Only the thing is, sliding scale which had 10 division has been replaced by circular scale which has 100 division. That's it. Okay, and which division you have to see, which division, which 45, 50, 99 or 75, which is coinciding with the reference mark when you keep an object here. Okay, and then pitch. The least count is pitch by number of divisions on the circular scale. Pitch I told you. the distance that the circular scale advances when you give one complete rotation to it, is it not? How much distance it has moved on the main scale. So in this standard thing, it will move by 1 mm. Standard scale it will move by 1 mm. This all things will be given, okay, divided by number of divisions. Number of divisions can be 50, 100, 200, whatever it is you substitute. Generally it has 100, so 1 by 100 is 0.01, and then that will be 0.001 centimeter. So you will get the total reading here. So this is about the 2 meter scale, that is a standard thing, vernier calipers and screw gauge. Most of the time questions are being asked in the competitive exam, not just based on this formula. The complete knowledge you should have about the least count, okay? Only then you can do the problems. Is it fine? You can make a note of this.